All right, it's time to get ready for our fall final. And so for it, here's the blueprint of what the final is going to look like. For the test, there's going to be 30 questions, 20 multiple choice, 9 interactive, and the honor code. So 29 questions really. And so we'll get into it. On number 1, it's asking for the domain and range. As a reminder, domain are the x's, which is going to go from left to right. And then range is the y's going from bottom to top, or low to high. And so everything's going to be in this order. And so for the first one, figure A, this is a discrete graph because it's just some points. They're not connected. It's not a continuous graph. So for this, we're just going to list all the points. And so we're going to make this little funky bracket. And the first x value going left to right, we've got -3 and then -1. And we're looking at the x's, 1 and then 3. And then we'll close it. So we're just going to list all those x's. Then for the y's, we'll do the same thing. So the lowest y is going to be -1 and then 0 and then 1 and then 2. For figure B, it has an open circle right here, and then it has an arrow on this side, which means it's going to keep going forever up and to the right. So for the domain, the furthest left it goes is -1, and then it's an open circle, so it's going to be less than x, and then I don't have to put anything on the right because it goes forever. So you can write it like this, or you could write x is greater than -1. Both of these are correct. The open end is going to be on the x side. For the range, we'll do the same thing. The lowest point is -3. It's open, so it's not going to have the equals, and it goes up forever. And so I don't have to put anything on the right side, so you could write it like that. Or you could write y is greater than -3. Again, both of those are good. For figure C, now we have a closed circle and then an arrow over here, which means it goes forever down and to the right. So for my x's, the furthest left it goes is -2. It's a closed circle. And then because it goes forever, I don't have to put anything over here. And so again, you could write it like this. Either way works. For my y's, the lowest it goes is forever, so I don't need that side. But the highest it goes is 4. So my y is everything less than or equal to 4. For figure D, we have an open circle over here and a closed circle over here, so we don't have an arrow. And so for my domain, the furthest left it goes is -3. It's open, so no equals. The furthest right it goes is 4. And that one's closed, so it's going to have the equals bar. The range, the lowest it goes is -4. It's open, so no equals. We're doing the y. The highest it goes is 3, and it's closed, so it has the equals. For the next one, it says a bouncy house can be rented for $50 per hour for 4 hours, 6 hours, or 8 hours. The cost in dollars to rent the bouncy house is a function of the number of hours the bouncy house is rented. And so we can either rent it for 4, 6, or 8 hours. Those are going to be the x's. To find the y's, we're going to multiply by 50 because it's $50 per hour. So if we rent it for 4 hours, 4 times 50 would be 200. If we rent it for 6 hours, 6 times 50 would be 300, and 8 times 50 is 400. So this is going to be like figure A up here that had the discrete graph, a bunch of dots. So my domain is going to be 4, 6, 8. My range is 200, 300, 400. Then lastly, a computer programmer charges $50 per hour to develop an app for a company plus a $100 setup fee. This can be modeled by the function. There's our function, where x represents the number of hours. So for this one, if I were to draw a sketch of this, or if I put it in Desmos, it would look something like this. The y-intercept is 100, and then it has a slope of 50, which means it's going to go up 50 over 1. So it's going to look anything like that. And so it's going to be going up and to the right forever. So for the domain, the furthest left it goes is 0. It's closed, so it's going to have the equals. And then it's going to go to the right forever. So we could write like that, or we could write it like that. Either way works. For the range, same thing. The lowest it goes, this is 100. So the lowest it goes is 100. and it goes up forever. So again, we could write it like that. All right, so the next one, write the domain for the situation represented in the graph. So again, domain is going to be furthest left or furthest right. And so the furthest left it goes is 0. It's closed, so it's going to have the equals bar. The furthest right it goes is 10, and again, it's closed, so it has the equals bar. When comparing real-world graphs to linear function graphs, what consideration should be made when determining domain and range? So with real world, a lot of times in real world, you may or may not have negatives. Like we may have negatives when it comes to money because we can spend more than we have. But you're not gonna have negatives when it comes to side lengths and things like that. And so in the real world, you may not have negatives, but also in the real world, it may not be a continuous. It may be like this graph right here, where it's a discrete graph. And so it could be discrete rather than continuous. Like the bouncy house problem too. It doesn't include the 5 hours or the 7 hours because you can only rent it for the 4, the 6, or the 8, not everything in between. All right, let's go on to the next page. So number 2, Maddie's old cell phone drains battery 5% per hour. Each day she starts with a full charge at 100%, which linear equation best represents the remaining battery life for B of H for H hours of usage? So she starts with 100%, and then every hour it's subtracting 5% per hour. And so that would be the equation in percent form. But when you look down here, none of them look exactly like that. But they've converted the percentages to decimals. And so as a reminder, to change a percent to a decimal, so like if I have 83%, you just take the decimal and go 2 places to the left. And so that's the equivalent of 0.83. And so 5% would be the same thing as 0.05. And now it makes a little bit more sense. We've got 0.05, so the 0.05 is with the H and being subtracted. That's good. Nope. Nope. Nope, and so it's got to be B, because the 100%, if I move the decimal over, that's 1, and then it's subtracting 0.05 per hour. So the whole battery is being deducted by the 0.05 per hour. Number 3, use the data from the table to write the linear function in slope-intercept form. And so for this, we could just go into Desmos. And so in Desmos, we'll make this table. We need at least 2 points, and then it will do all the work for us. And so let's take a look at it. All right, so here's my computer with Desmos. I went ahead and put in the table. Like I said, we just need at least 2 points. And so I did these 2 points, and then we're just gonna click this line to connect the dots, and it brings up, there's the equation of the line in slope-intercept form. And so my equation is y equals 8x plus 12. So like we found in Desmos, the equation is y equals 8x plus 12, and that's the answer. Number 4, the conversion from kilometers to miles can be represented by a linear relationship. The graph shows the linear relationship between y, distance in kilometers, and x, the distance in miles. Which equation represents this situation? And so we've got these 2 points, 25, 40, and 100, 160. And so using those 2 points, we could find the slope algebraically on pen and paper, or we can go into Desmos to figure out what the slope is. But then for this other point, this is in point slope form, which as a reminder is y minus y1 is equal to mx minus x1. And so the x coordinate goes with the x, the y coordinate goes with the y, and then we have the slope. And so for these, they're all using the 25 and the 40. And so looking at these points, this one right here is my 25, 40, where 25 is the x and 40 is the y. And so I should see the 25 with the x. And so that one checks, that one checks, that one doesn't, that one doesn't. And then the 40 should be with the y, that one checks, and that one checks. And so it's got to be either B or D. So now we just got to verify, is the slope 5 over 8 or is the slope 8 over 5? And so that's where I'm going to go into Desmos, and I'll put in both of these coordinates, and we'll figure out what that slope is. And so let's go to the computer. All right, so in my computer again, I made a table. And on the table, I put in those 2 points that we had. And so I'm going to connect those 2 dots. And it brings up my slope is 1.6. And so our slope on the paper was a fraction. And so we need to figure out which one's equivalent to 1.6. So I could put in 5 divided by 8, and that's 0.625. So that's not correct. And so we could flip it around. Now we'll do 8 divided by 5. Whoops. I got rid of the whole thing on accident. I'll put it back up there. There we go. And so now we'll do 8 divided by 5. And that one's 1.6. That matches. So my slope is the 8 over 5. So like we just found in Desmos, the slope is the 8 over 5, not the 5 over 8. So D is the correct answer. Number 5, write the linear function in slope-intercept form from the graph. And so again, I've got 2 points. We could just plug this in Desmos. And so this point right here is 5, negative 5. And then this point over here is negative 5, 1. And so one option we could do, just like we did on the previous one, we could plug this into a table in Desmos and it'll give us the answer. We could also do it without Desmos. And so without Desmos, I need to know what is the slope and what is the y-intercept. And so we did Desmos a couple times. I'll do this one without. Looking at the graph, it goes through the y-axis at negative 2. So the slope is, the y-intercept is negative 2. For the slope, I'll use the 2 points it gave us, and we want to know what is the rise over the run. And so I connected these 2 points with a triangle, and it goes down 1, 2, 3, 4, 5, 6, and it goes over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my slope is 6 over 10, but more specifically, the line is falling to the right, so it's negative 6 over 10. But we always want to simplify where we can. For negative 6 over 10, if you struggle simplifying, you can put this in Desmos and it'll simplify for us. But we can divide both of these by 2. If I divide negative 6 by 2, it becomes negative 3. 10 divided by 2 is 5. And so my slope is negative 3 over 5. And so I'm going to put this in mx plus b. So my slope is negative 3/5, and then x, plus my y-intercept was negative 2. So I didn't need to put that plus sign right there, but I already did it. And so I'll just leave it. So you could have written like that, or you could have written just negative 3/5 x minus 2. Both are the same. The total online cost Y for X tickets to the Houston Zoo includes a flat fee for processing and a cost per ticket. One student purchased 2 tickets for $42. Another student purchased 5 tickets for $102. Which linear equation represents the total cost in dollars for X tickets? All right, so for this one, I've got 2 points. I've got 242 and I've got 5,102. We have all the information we need. I can put these 2 points into my Desmos and we'll see what it is. So let's check it out. All right, so I put in those points into Desmos exactly as they are. We'll connect the dots, and there's my equation. Y equals 20x plus 2. And so that's what I'm going to be looking for. All right, so in Desmos, we got y equals 20x plus 2, which is C. All right, going on to the next page, number 7. Says line A is shown on the coordinate grid. The table of ordered pairs represents some points on line B. So we've got line A and line B. Write the system of equations represented by lines A and B in slope-intercept form. And so for the first one, we'll do it like we did on the previous. I need to know what is the slope and what is the y-intercept. So this one goes through the y-axis at 1. So y equals, we're going to have plus 1 at the back. That's the y-intercept. And then for the slope, from here to here, or I could do here to here, either one. I'll just do the smaller one because I don't have to simplify as much. It goes up 1, 2, 3, and it goes over 1, 2, 3, 4. And it is rising to the right, so my slope's going to be 3 over 4. And so there's the equation of line A, and now it's for line B. Again, I need to do at least 2 points, doesn't matter which one, but we'll plug in 2 points in Desmos, and it'll give us all the information. So let's check it out. All right, so here's line B in the table in Desmos. And again, I'll click the add regression to connect the dots. And there's my equation, y equals negative 4x minus 8. All right, so in Desmos, we got the equation for line B is y equals negative 4x minus 8. Number 8, Wilfredo caught 25 fish while on a fishing trip. The total weight of the bass and trout fish was 125 pounds. The average weight of the bass was 4.5 pounds. The average weight of a trout was 8 pounds. Which system of equations can be used to find x, the number of bass, and y, the number of trout fish that Wilfredo caught? So for this one, we know that the number of, the number of bass, which is x, plus the number of trout, which is y, all together he caught 25 fish. And so that doesn't include the weights, that's just the number of fish. So the number of bass plus the number of trout equals 25. And so let's check through. Nope. Yep. So it's either C or D. Next off, the bass, the average weight was 4.5. So if you do the 4.5 times the number of bass, that'll be the total weight of all the bass together. For the trout, the average weight was 8 pounds, so 8y. So however many trout they caught times 8, that gets the total weight of the trout. And altogether, the weight was 125 pounds. So this one didn't include weight. This one included all the weights. And so we have 4.5 should be with the x, not the y. And so C is the right answer. A system of equations is graphed on the grid. Which system of equations best represents the graph of these two lines? So we could plug this into Desmos and see if it matches this. And then if it doesn't, we can go to the next one. I'm going to go ahead and do it without Desmos, but you could, again, graph that in Desmos, see if it matches. Graph that in Desmos, see if it matches. Without using Desmos, we'll just find the equation of both lines like we've done already. So this line has a y-intercept of 3. So y equals plus 3, and the slope, looks like it goes through this point, goes up 1 and over 2. So 1/2 x plus 3. So there's one line. I can go ahead and check through it. 1/2 x plus 3, that one's good. Negative 1/2 x plus 3, that's not good. 1/2 x plus 3, that's good. That's not good. So it's either A or B. So for my other line, this line right here, it goes through, the y-intercept is -2. And then, again, I could use the same point to see what that would be. So it goes down 1, 2, 3, 4, and over 2. And so that slope would be 4 over 2. It's also falling to the right, so it's going to be negative, which is going to be -2. So we're going to have -2x minus 2. Which is this one right here. So B is the correct answer. And again, to verify, we could put it in Desmos, which I'll show you now. And so since I already found B is the right answer, I'm now just going to check it in Desmos. All right, so here's the graph of what we just did on the paper. I put it into Desmos, both equations. And if we got it right, it should match our graph on the paper. And so as a reminder, here's our graph on the paper, which has an intersection point at -2, 2. And looking at the graph on Desmos, it also has an intersection point at -2, 2. The lines look pretty much identical. If I look at those lines next to the Desmos, pretty much the same lines. And so we did get it correct, and we checked it in Desmos as well. All right, number 10, the table of ordered pairs represents some points on the graph of two different lines. Which system of equation best represents the graph of these two lines? So this one's a little bit tricky because they are in standard form, but that's okay. We have the table, and so here's the x's, here's the y's for one equation, the y's for the other equation. So I'm going to go ahead and put both of these in Desmos just to see what the equations would be. And so let's check that out. All right, so I put in both tables separately. So one of the tables gives me an equation of y equals -x plus 5, and the other one gives me an equation of y equals 2.5x plus 1. And so 2.5, if I were to come down here and put in 2.5 and change it to a fraction, would be 5 over 2. And so 5 over 2x plus 1. And so there's the two equations that we need to see where they are. All right. So on Desmos, we had y equals -x plus 5, and we had y equals, I believe it was 5/2 x plus 1. So there's our two equations in slope-intercept form. Now we need to see which one matches. The easiest one to see which matches, there's no fraction, no other number with the x, so we can just move this x to the other side. And so for the y equals negative x plus 5, we can add this x to the other side to put it into standard form. So we're going to have x plus y equals 5. And so that's going to be one of our equations. X plus y equals 5, that one checks. X plus y equals 5, that one checks. That's an x minus y, that's a no, and that's a no. So it's either going to be A or C. And so we need to solve for one of these to see which one matches this one. And you can just pick one and see. We'll try A out. So for A, 2y minus 5x is equal to 2. And so to solve this one for y, we're going to move the x to the other side. So I'm going to add the 5x to the other side of the equation. So the x's are gone on the left, so 2y equals 5x plus 2. And then we'll divide by 2 on both sides to everything. So that 2 is gone. Y is equal to 5 halves x plus 2 divided by 2 is 1. That's what we wanted. It matches. And so A is the correct answer. Number 11, determine the slope of the following equations. So again, remember the slope, we have y equals mx plus b. And then looking at this one, we also have y minus y1 equals mx minus x1. Here's our two equations, the slope-intercept form and the point-slope form. The m should be either attached to the x or in front of the parentheses if we're in this form. So on this one, attached to the x is 4, so the slope is 4. On this one, here's the x right here, so the number attached is negative 6 over 7. On this one, this is the point slope form. The number in front of the parentheses is 3. And then lastly, this one, harder to see, it's in standard form, so we've got to convert it to slope-intercept form. So we're going to start off by subtracting 3x on both sides. So the negative 4y drops down. And these two are just both going to drop down as they are, negative 3x plus 24. Then last step, we're going to divide by negative 4 to everything. So y is equal to negative over negative is a positive, and then that's minus 6. And so that's going to be the slope right there, 3 over 4. All right, number 12. On this one, it's to determine the slope given the following information. So given a table, you can find it using the equation m equals y2 minus y1 over x2 minus x1, and just use 2 points, plug it into the formula, or you can just go to Desmos. And so we'll go to Desmos and check it. I'm also going to go ahead and do B as well, because B we can also just put in Desmos. Both of them will give me the answer. And so I'm going to go ahead and do A and B both in Desmos. All right, so here's my tables for both A and then B. And so for A, you need at least 2 points. So I picked those 2 points. We're going to connect it. And then again, the slope is that number right in front of x. My slope on this one is negative 3. Then for the next one, again, I'll connect the dots. Come down here, the slope, it's negative 0.6666666 repeating. And so if you're not sure what fraction that is, we may actually need to do the y2 minus y1. And so we can change this and we'll just do the exact same thing. We'll do y2 minus y1, so we'll do 5 minus negative 9. And then I forgot to do the fraction, so we'll highlight it and do the fraction. And on bottom, we're going to subtract the x's, 0 minus negative 6. My slopes weren't matching up, and then I realized I had a typo. There should have been a negative 9 up here. Now my slopes are matching up, 2.33 repeating. So now I can click that fraction button, and let's see, there we go. And there's my slope for B. So my slope for A was the negative 3. My slope for B was 7 over 3. All right, so like we just found, for letter A, the slope was negative 3. And then for letter B, the slope is 7 over 3. Then for letter C, we just need to pick 2 points, and we'll count the slope. So here's a point right here, and here's a point right here. And so we want to see how far does it go down and over. This line is falling, so it's going to be a negative slope. It goes down 1, 2, 3, and goes over 1, 2. So negative 3 over 2. All right, next one, letter D. This one's a little bit on the trickier side. What must the value of r be in order for these two functions to have the same slope? So there's f of x, here's g of x. We need to figure out what is the slope of g of x. We're going to get the y by itself. So 3y minus 4x is equal to negative 15. And so to get that y by itself, we need to move the negative 4x by adding it to the other side. And then we'll divide by 3 to everything. So y equals 4 over 3x minus 5. And so this is what matters right here. The slope is 4 over 3. And it said, I want to have the same slope. And so for this one, we've got to use the equation m equals y2 minus y1 over x2 minus x1. And as we do it, the total slope I want it to be is 4 over 3. So on top, we're going to have with the y's, we have the r. On bottom, we're going to have our x's. And here's what we want to do. We want to make it match this. And so would 3 minus 6 get 3 or 6 minus 3? We're going to do 6 minus 3. So 6 minus 3 is going to go on bottom. And then on top, we're also going to have r minus 9. So 6 minus 3 is 3. That checks. Now we need r minus 9 to equal 4. So r minus 9 is equal to 4. So to solve for that r, we'll add 9 to the other side to find r is 13. All right. Zach bought concert tickets online. The online website charges a one-time fee for using their website in addition to the price for each ticket, T. The function C equals 950 plus 2450T can be used to find the total cost of the online purchase, determine the rate of change and y-intercept, and state in words what they represent in this situation. So rate of change, as a reminder, that's our slope. That's the m value. Anytime you see rate of change, that's slope. Slope is going to be the number connected to the variable, which is going to be 2450. And so 2450, based on this situation, is the price for each ticket. And then the y-intercept, that's the number by itself, is the 950. If we look through it, that's the one-time fee. Number 14, Meredith purchased a new car the first year after working in her new job. The table shows the linear relationship between y, the value of the car, after depreciation, and x, the number of years Meredith owns the car. Complete the statement that describes the rate of change, again, that's slope, of the value of Meredith's car with respect to time. Circle the correct answer in parentheses. So the value of Meredith's car, increase or decrease. So if you look at her car, it's decreasing at a rate of, and we want to know how much it's decreasing by. And so again, we can just go into Desmos. Or we can see from year 0 to year 1, how much did it decrease? So from 24,200 to 21,200, that's $3,000. So it decreases by $3,000 per year. All right, number 15, the graph below shows how the volume of a gas changes as the temperature changes and the pressure remains constant. Calculate an approximate rate of change, so again, slope. And here's the thing, approximate, in the volume of the gas. Circle the correct answer in parentheses. As the temperature increases, so as this is going this way, the volume of the gas is also increasing. It's a positive slope. And so for this one, it's kind of tricky to see. They don't give us 2 dots, but we're going to try to find 2 places it goes right through it. And so I think it goes through right there. And, oh man, it's tricky. We'll go right there. So again, it's really hard. I may have gotten it off a little bit, so our answers may differ. It does say approximate, and so it could be a little bit off, just depending. On the test, it should have some good dots that we can see. But for my coordinates, this coordinate right here, every line is worth 5. Because it's 5, 10, 15, 20, 25, 30, 35, 40. Every line is 5. So this line right here, that's going to be 90 is my x. And then the y value, over here, every line is 1. And so it's right here, that's going to be 29. And then for the other point down here, the x value is right there. That's going to be 30. And the y value, it looks to be 24. And so we're going to plug this into Desmos to see what the slope is. So again, I put the two coordinates into Desmos exactly as they are. And we're going to press that line to connect the dots. And it pulls up that decimal right there, which is kind of a long decimal. I don't know what that fraction is. You could just put that decimal, but if you wanted to convert it to a fraction, the easiest way, again, is to do that slope formula, the y2 minus y1. And so I'll do 29 minus 24 on top. That's subtracting the y's. And then 90 minus 30 on bottom. And so there's the fraction 1 over 12. And so the slope should be 1 over 12. All right, so as we just found, the rate of change, the slope is 1 over 12. Number 16, the graph of a line is represented by the equation 4x minus 5y equals 20. Which value represents the rate of change of y with respect to x for the equation? That's a lot of words, but here's the important part. Rate of change. What is rate of change? The slope. So we need to figure out what is the slope. So 4x minus 5y is equal to 20. We need to get the y by itself. So we're going to subtract 4x to the other side. Bring down the negative 5y. These two will drop down as they are, the negative 4x and the positive 20. And then we'll divide by negative 5 to everything. And so we get y is equal to a negative over negative is a positive. And then 20 divided by negative 5 is negative 4. And here's what matters though, because we want to know the slope. Positive 4 over 5. Number 17, Zeta is comparing two moving truck company prices for our upcoming move. Each company charges a fixed price plus additional cost per mile the truck is driven. Moving company A, moving company B. Identify the rate of change. Again, rate of change, that's my slope for each moving company. So for the first one, we need a couple points. So it looks to be a good point right there and another good point right there. And so the rise goes up from 30 to 40, that's 10. And it goes over from 10 to 20, which also is 10. So it's going up 10 over 10, which means it's 1. Yep, and so it's going up 10 over 10, so 1. And then for this one, the rate of change, I need to put in two of these into Desmos, or we could do it algebraically. But I'll go ahead and plug it into Desmos to see what we can get. All right, so here's my table. We'll connect the dots. I want to find the slope. It's 0.75. And so 0.75, that's not a repeating decimal, so I can just type it down here, make it a fraction. There it is right there, 3 over 4. So the slope of B, moving company B, is going to be 3 over 4. All right, so moving company B is 3 over 4. Number 18, identify the key features of the linear function graph below. The x-intercept is where it crosses the x-axis, which is going to be 4. Or you could write 4, 0. Both are the same. The y-intercept where it crosses the y-axis is negative 6. Or again, you could write 0, negative 6, because the y value is negative 6 on the y-intercept. The slope of y with respect to x, again, that's just slope. How far does it go up and over? Well, it goes up 6 and over 4. So it's 6 over 4, which reduces to 3 over 2. All right, next one, 0. That's another way to say x-intercept. Where it crosses the x-axis is 3, or 3, 0. The y-intercept is 6, or 0, 6. And then the slope, again, the slope goes down 6 and over 3, and it's falling to the right, so negative 6 over 3, which is negative 2. 19. The graph below shows a relationship between the amount of fuel in gallons remaining in a truck and the number of hours the truck has been driven. Which statements are true about the graph? Select 3 correct answers. All right, the initial amount of fuel in gallons was 200. Fuel, initial, looks to be about 200. Check. The initial amount of fuel in gallons was 20. Nope, it was 200. The number of hours driven to run out of fuel was 200. And so as you go, it's running out of fuel. It's running out of fuel. Up, now it's empty. There's no fuel. The time driven was 20 hours, not 200. Not C. The number of hours driven to run out of fuel was 20. Yes, that's what we just found. The amount of fuel remaining was decreasing at a rate of 10 gallons per hour driven. And so if we look right here, that's 2 hours. After 2 hours, it has lost 20 gallons. So if you simplify that, for every 1 hour, that's 10 gallons. So the amount of fuel remaining was decreasing at a rate of 10 gallons per hour driven. Yes, that's correct. The amount of fuel remaining was increasing at a rate of 10 gallons per hour. No, it wasn't increasing, it was decreasing. All right, going on to number 20. Graph a line with a 0 of 3. That again, that's an x-intercept. So an x-intercept of 3 and a y-intercept of -5. X-intercept of 3, y-intercept of -5, and then we'll make that line as best we can. Could be helpful to use a ruler, or you can try to freehand it like I did. Graph a line that passes through the points -5, 6, and 5, -2. So -5, 6, and 5, -2. Identify the slope and the y-intercept. So this one, I want to make this one a little bit more exact so I make sure to get that y-intercept. This one's going down and over. So it's going down 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so -8 over 10 because it's falling to the right, which can simplify to be -4 over 5. So 1, 2, 3, 4, 1, 2, 3, 4, 5. And we found because we did that slope, the y-intercept is 2. Graph the line represented by the equation 3x plus 4y equals 12. And so we need to get the y by itself. So we're going to subtract 3x to the other side. And then divide by 4. So y equals, that's going to be -3 over 4x plus the y-intercept is 3. So we're going to start, my y-intercept is 3. Then the slope tells me I'm going to go down 3, right 4. 1, 2, 3, 1, 2, 3, 4. Or up 3, 1, 2, 3, left 4, 1, 2, 3, 4. Each answer below is incorrect. Explain the error made in arriving at the incorrect value. They said the slope is 3/4. It should have been -3/4. And so it should have been negative. The y-intercept is 4. The y-intercept is 3. Should be 3. All right, for our next one, we're going to start by distributing this -2. So y equals, that's -2x. -2 times -3 is +6. And then we'll combine like terms. So y equals -2x plus 1. So the y-intercept is 1. I'm going to start at 1. The slope is -2 or -2 over 1, because anytime you have a whole number, you can put a 1 underneath. So we're going to go down 2, right 1, down 2, right 1, down 2, right 1. And there's our line. All right. So each answer below is incorrect. Explain the error made in arriving at the incorrect value. The 0 is 1. No, it goes right in between. It should be 0.5. The line can be rewritten as y equals -2x minus 8. No, it's -2x plus 1. All right, which graph represents the solution set? And so for this one, because it has the equals, it should be a solid line. Because of that, I know I can cross off it's not A and it's not C. Because my y is positive, I know I'm not going to flip the inequality. And so it's not going to change. It's going to be greater than, which means we're going to shade above, which is not going to be that one. So it's going to be B. And so we did process of elimination without even solving for this, just by knowing it's solid. And because we're not going to be flipping it, it's shaded above. Number 22, Kiara is buying a notebook, paper, and graph paper and can spend no more than $30. Each pack of notebook paper costs $5 and each pack of graph paper costs $6. The inequality, y is less than or equal to negative 5, 6x plus 5, represents all possible combinations of x, the number of packs of notebook paper, and y, the number of packs of graph paper Kiara can buy. If Kiara wants to buy 5 packs of notebook paper and 2 packs of graph paper represented by that 0.52, is that part of the solution set? So let's graph this first. So we're going to start at 5, the y-intercept, and we're going to go, because it's negative, down 5 and right 6. It's a solid line because it has the equals. And then because it's less than, we're shading below. So anything inside the shaded region would be a good solution. And so 5, 2, if I go to 5 and 2, is 5, 2 inside the shaded region? No. The graph of y equals negative 1/3 x minus 1 is shown on the grid. Which ordered pairs in the solution set of y is less than negative 1/3 x minus 1? So less than means this would be a dotted line or dashed line and shaded below. So I want to see which one of these points are inside this solution. So negative 3, negative 2, yes. 0, negative 1, that's on the line? No. On a dashed line. If it's on the dashed or dotted line, it doesn't count. 2, 3 is up here. Again, that's a no. And negative 4, 1, no. All right, 24, graph the inequalities below. And then circle all points that are solutions. So x minus y is greater than negative 2. There's not a whole lot of room on this one. I'm just going to come down here and do it. And so x minus y is greater than negative 2. So we're going to start off by subtracting the x to the other side. Negative y is greater than negative x minus 2. And then to get the y by itself, we got to divide by negative 1. Because we divided by a negative, we have to flip the inequality. Positive x, positive 2. So we're going to start at 2, and it's a positive 1 slope, so up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. And it's going to be a dashed line going through those lines, or those corners. All right, there we go. And this one is less than, so we're going to be shading below. And now let's see. So O2, it's on the dashed line, so that's a no. O negative 2, that's a yes. 2, 0, that's a yes. 0, 4, that's a no. 0, negative 4, that's a yes. And 0, 0, that's a yes. All right, so again, not a whole lot of room. We'll come down here. 3x minus 2y is less than or equal to 12, so we'll subtract 3x to the other side. Negative 2y is less than or equal to negative 3x plus 12. Divide by negative 2. And we have y. Because we divided by negative, we got to flip the inequality. Negative over negative is a positive. Minus 6. So we're going to start at negative 6, and we're going to go up 3 over 2, because that's the slope. Up 3 over 2. Up 3 over 2. It's a solid line because it has the equals. And we're shading above. So 0, negative 6 is on the solid line, so it counts. 0, 0 counts. 2, negative 6 outside, nope. Negative 5, 1, yep. 5, 0, nope. And 6, 7. 6, 7 is in the solution set. All right, letter C, which ordered pair is in the solution? And so again, we're going to start at 4, and we're going to go up 1 over 3. Up 1 over 3. It's a solid line. And we're shading above. So negative 6, 1. Nope. Negative 1, 6. Yes. 6, negative 1. Nope. 1, negative 6. Nope. Graph the solution set. Y is less than negative 6x. There's nothing out here, so that's a plus 0. So when y-intercept is 0, we're going to go down 6 over 1. Or up 6, left 1. This one is a dotted line. And we're shading below. Number 25, determine the value of x, which makes this statement true. You could do this algebraically, or you can do it in Desmos. I'm going to go ahead and just do it in Desmos. And so in Desmos, you're going to split it at the equals. This side you're going to put in for y1. This side you're going to put in for y2. All right, so I put in the two sides into the y equals. And so here's the left side, here's the right side. And once you do that, you just want to find where they intersect. So they intersect at -5, -3. Y wasn't part of our original equation, so all I care about is the x. So our answer is -5. All right, so like I said, the answer would be -5. For number 26, same thing. I'm going to split it the equal sign. We're going to put this side into y1, and we'll put this side into y2. And again, we'll find where they intersect. Instead of putting w, I'm going to put x's everywhere there's w's. And so I'm going to plug that in. All right, so I've plugged in the two equations exactly as they are. And I can't see where they intersect. And it looks like they will intersect, but I just can't see it right now. And so I'll zoom out a little bit. And now find that gray dot. There's where they intersect. So the x value is 42. So that's going to be the answer, 42. All right, so like we found on Desmos, the x value is 42. Or sorry, w value is 42. All right, going to the next one. Number 26, determine the value of y, which makes this statement true. Again, y1, y2. And on this one, in fraction form, y1 and y2. All right, so here's number 26. And so if I zoom in on the intersection point to make sure I get the intersection point, it looks like my answer is 8. And so that's where they intersect, 8. All right, and then for number 27, if I find it, it's -1.777 repeating. It did say it went in fraction form, so we're actually gonna have to solve this one by hand. All right, so like we found, number 26, the answer was 8. For this one, it was 1.777 repeating. But again, since it's not in fraction, we need to find it by hand. If it was multiple choice, I could plug in the fractions and see which one's equivalent, but I don't have that. So 6m, we're going to distribute the -2. -2m plus 14 is equal to 3. We're going to distribute the -5 inside, -5m minus 5. Then we'll combine like terms. Over here I have 4m plus 14 is equal to, I've got 3 minus 5, so -5m minus 2. I'm going to move all my m's over here, so we're going to add 5m over here. So 9m plus 14 is equal to -2, and then we'll subtract 14 to get the m's by themselves over there, and then divide by 9. And so we get m is equal to, sorry, that was a -1.77, -16 over 9. And I'm going to go into my Desmos real quick and just check that. But if I put a -16 divided by 9, it is -1.77 repeating. And so that is the correct answer. Number 28, Isaac and Pierre ordered a rectangular trampolines with the same area, but different dimensions. If Isaac's trampolines are this, and Pierre's trampolines are this, what is the value of x? So area is length times width. So for one of them, it's going to be 4 times 11 minus x. So that's Isaac's trampoline. And then for Pierre's trampoline, it's going to be 3 times 2x plus 3. And then we got to solve this one. You can solve it by hand. You can solve it in Desmos. Either way, I'm going to go ahead and just solve it by hand. So distribute the 4 is 44 minus 4x. Over here, that's going to become 6x plus 9. And then I'm going to add the 4x over here to keep my x's positive. So that becomes 10x plus 9 is equal to 44. I'm going to come up here because I'm running out of room. I'm going to subtract 9 on both sides though. So 44 minus 9, that's going to be 35 is equal to 10x. And then we'll divide by 10. And x is equal to 35 over 10, which is 3.5. Number 29, Cedric compares two cell phone plan costs. The equation below represents the intersection of the two plans after t minutes of usage. Solve for t and explain clearly what it represents. So again, we can do it by Desmos or we can do it by hand. I'll go ahead and do this one by Desmos. And so again, this would be y1, y2. All right, so I put both equations in, but all I see is one line. So we need to zoom out. Up there's the other line. And find where they intersect. Up there it is, up here somewhere. So we'll zoom in so we make sure to get the intersection point. And it's somewhere in here. So let's click and see if the gray dot comes. There's the gray dot. 135. So the x value is 135. So the t value is 135, and that represents t is the number of minutes. I believe it is. Yep, t minutes. So it's the number of minutes when plans are equal. All right, number 30. Adam and Aiden went to a store with used books to purchase mystery novels and sports biographies. The cost for each mystery novel is the same price. The cost for each sports biography is the same price. Adam purchased 8 mystery novels and 1 sports biography for $35. Aiden purchased 4 mystery novels and 3 sports biographies for $25. What is the cost of each mystery novel? So I'm going to have mystery novels as my X, sports as my Y. So for Adam, he had 8 mystery plus 1 sports, and it equaled 35. And then for Aiden, he had 4 of the mystery plus 3 of the biographies for 25. So now we want to graph these in Desmos and find where they intersect. And so for the first one, we just want to move the 8x over. And so y is going to be equal to 35 minus 8x, or negative 8x plus 35, however you want to write it. For this one, I'm going to move the 4x over. So we have the 25 minus the 4x. And then we're going to divide by 3. It's kind of a shorthand way of doing all the steps. And now we're going to put these into Desmos. All right, so here's the 2 equations in Desmos. And we're going to go over here, find where they intersect, and it's at 4, 3. All right, so my answer was 4, 3. And like we said, X is the mystery, and Y is the sports. So to answer the question, how many mysteries? The answer would be 4. All right, we're almost done. We're getting there. Number 31. Becca ordered breakfast items, including donuts, kolaches, both days last weekend. The price of donut is different from the price of a kolache. Table shows the number of items purchased on both days and the total cost each day. All right, so here we go. I'm just going to put an X with this, a Y with this. We'll add it together. Got that. X with this, Y with this. Add it together. Got that. And so we're trying to find what is the price of the donut, what is the price of the kolache. And so just like we did on the previous one, I need to get the Y by itself so I can put it in Desmos. And so for my first equation for Saturday, we're going to take that original. We're going to subtract over the X and divide by the Y. For Sunday, we're going to do the same thing, 222.50. And then we're going to subtract over the X and divide by the Y. So we're going to put these 2 equations in Desmos, find where they intersect. All right, so here's the 2 equations put in Desmos. There's the gray dot where they intersect, 2.5, 2.75. All right, so the intersection point was 2.5, 2.75, where X was the donut, Y was the kolache. So the cost of a donut, $2.50. Cost of a kolache, $2.75. 32, a system of linear equations is shown. Select all statements that are true. All right, so we have that one. Let's go ahead and solve this one. And so 6x minus 2y is equal to 10. So we'll subtract 6x to the other side. And these 2 drop down as they are. and then we'll divide by -2 to everything like we've been doing throughout this packet. Y is equal to, that's be positive 3x minus 5. What do you notice about these? They're the exact same equation. So select all statements that are true. The slopes of these lines are equal. Yes, they are. The lines are parallel to each other. No, they're the same line. They're not parallel. The system has a solution at 3, 4. Technically, yes, because they have solutions everywhere. The system has no solutions. No, they are systems everywhere. The system has infinitely many solutions. Yes. Every point on each line is a solution for both lines. Yes. Let's make sure that's right. The system has a solution at 3, 4. If I were to plug in 3 times 3 is 9, 9 minus 5 is 4. Yes, that does check. All right. The solution to the system of equations is -1, 4. What does this mean? It means if we substitute in -1 into x and 4 into y, it should be the same in both. So if you substitute x equals -1, y equals 4 into both equations, you will get a true statement for each equation. Yes. The intersection of these lines is at the point -1, 4. Yes. The point -1, 4 lies on both lines. Yes. All the above are true. A trapezoid has sides whose lengths are presented by polynomials as shown, where x is a positive integer, which expression represents the perimeter, which means add all sides of the trapezoid. So we're just going to add everything together. We're going to combine like terms. And so we're going to combine our x's first. And so I'm going to put it in Desmos, and then I'll let you know what I get. But inside Desmos, I'm just going to do all my x's first. So we're going to do 2/3. I'm not going to put the x, but 2/3, and then plus 2, and then plus another 2/3, and then plus another 2. And so I'll show you my Desmos. There's all my x coefficients, and I'm going to make it a fraction, 16/3. And so when I add all those x's together, I should get 16/3x. Next off my numbers, I have -5/6 and 2/3. And so if I add up -5/6 plus 2/3, there's my -5/6 plus 2/3. I'm going to change that to a fraction. I get -1/6. And so my perimeter, by adding all the sides together and combining like terms, is 16/3x minus 1/6. 16/3x minus 1/6. That's B. Number 35, which expression is equivalent to this? Is just combining like terms. We're adding. And so there's no other m squared, so it's going to be 2m squared. Next off the m's, there's 3m and -7m, which is going to be -4m, because 3 minus 7 is -4. And then we have -9 and +4, which is going to be -5. So we're going to find that down here. -4m, oh, there it is right there, D. Which expression is equivalent to this? Because it's subtraction, that subtraction is going to distribute and change all the signs. So -4a squared, -5a, and +3. And now we'll combine like terms. 5a squared minus 4a squared is going to be 1a squared. A minus 5a is going to be -4a. 8 plus 3 is going to be 11. So a squared minus 4a plus 11 is a. 37, write an equivalent expression using distribution. And so this is multiplying, this all those rules of exponents. So 4 times 2 is 8. And when you multiply like bases, you add the exponents. There's a total of 3a's, so a to the third. Right here, we're going to distribute the -3x. That becomes -3 times 4 is -12. And then we have 2x's, so x squared. And negative times negative, that's going to be a positive. -3 times -2 is +6. And then we have the x. Right here, this is the FOIL, or the box method, either way you want to do it. But 2y times 4y is 8y squared. 2y times 3 is going to be 6y. -1 times 4y is -4y. -1 times 3 is -3. And then we'll combine like terms right here in the middle. And so we get 8y squared plus 2y minus 3. That's going to be the answer right there. This one, we're going to multiply the 2b to all three items, and then multiply the 5 to all three items, and then we'll combine like terms. And so multiplying the 2b, that's going to be 6b cubed. I'm going to write it up here. And then 2b times negative 4b is going to be negative 8b squared. 2b times 7 is plus 14b. And now I'm going to write this one down here, and I'm going to write it with the matched terms, the like terms. So 5 times 3b squared is going to be 15b squared. 5 times negative 4b is going to be negative 20b. And 5 times 7 is going to be 35. And now I'm going to combine like terms. So we get 6b cubed. Negative 8 plus 15 is going to be a positive 7b squared. Positive 14 minus 20 is a negative 6b, and then plus 35 at the end. 39, determine the area of each figure below. Area of a triangle is 1/2 the base times the height. I don't care about this length. I just need these two. And so we're going to multiply these two along with 1/2. So 1/2 times 6a times 2a squared minus a plus 8. So I'm going to do this first. 1/2 times 6a is 3a. And then we're going to distribute the 3a to everything. So that becomes 6a cubed. And then 3a times negative a is going to be negative 3a squared. And then 3a times 8 is going to be 24a. Area of a rectangle is length times width. So we're going to multiply these two together. So we're going to distribute. So 7b squared times 3b is going to be 21b cubed. 7b squared times negative 1 is negative 7b squared. Now we're going to multiply the negative 5. Negative 5 times 3b is negative 15b. And negative 5 times negative 1 is positive 5. There's no like terms, and so we're done. Number 40, which expression is equivalent to all of this for all values r and w? And so one thing you can do is you can plug in and see which one matches. I'll do it without. We're going to distribute this. 2 is going to go to everything first. So we have the 1/3 on the outside. That becomes 6 squared, which is 36, r to the 4th, and w squared. And then 2r cubed, w to the 4th. All right. So now we have 1/3 times 36 times 2. So numerically, 1/3 of 36 is 12. 12 times 2 is 24. So the number is 24. My r's, I've got 4 here, 3 here, so it's 7 total. W's, I've got 6. So 24, R7, W6. 41, which expression is equivalent to this? So numerically, 16 over 4 is 4. With y's, there's more on top, and there's 6 more on top. With z's, there's more on bottom, and there's 7 more on bottom. So that would be the answer. So 4y to the 6 over z to the 7th. All right. And the last page. All right. 2 students each simplify the expression below, compare their answers, and select the true statement about their work. All right. So I'm going to ignore theirs and just do it myself. And so we have 3m to the 5th, and that becomes n to the 8th over m squared n. 3 is the only number, so it's going to stay. There's more m's on top, and it's 3 more. There's more n's on top, and it's 7 more. So that should be the answer. 3m cubed, no. 3m cubed into the 7th, yes. So student 2 is correct. So no. Student 2 is correct because the exponent for n should be multiplied to yes. So B is correct. 43, what is the value of f of 12? We could just plug this in Desmos, and I'll show you that. But you could also, 12 is the x value, and so we're going to put in 1/2 2 minus 12. And on this one, we're going to put in negative 12, so it's 1/2 2 minus negative 12, which minus negative becomes a positive. So on this one, 2 minus 12 is going to be negative 10, and half of negative 10 is negative 5. For this one, 2 plus 12 is 14, and half of 14 is 7. Now I'll show you what it looks like in Desmos. All right, so in Desmos, I put in the original expression just as it is with f of x, and then put in f of 12, f of negative 12, and it spits out the answers negative 5 and 7. And that's what we had on our paper. And so Desmos can do all that work for you. All right, so number 44, exact same thing. We're going to plug in -7 into x and plug in 7 into x. And again, Desmos can do it for you. And so for the first one, we're going to do -3 times -7 plus 28 divided by 7. For the second one, we're going to do -3 times +7 plus 28 divided by 7. So for this one, -3 times -7, that's +21 plus 28 over 7. 21 plus 28 is 49, divided by 7 is 7. For this one, we have -3 times 7 is -21 plus 28 divided by 7. -21 plus 28 is 7 divided by 7, which is 1. And then for this bottom one, 10, if f of 10 equals -4, label each value as input or output. So 10 is the x, -4 is the y. So 10 is the input, and -4 is the output. This time we're going to label it domain and range. 0 is the x, y is the 4. So 0 is the x, which is the domain, and 4 is the range. A video game awards points to players after X levels completed according to this function. Which statement is true about this function? Let f of x represent the total points awarded. After 50 levels, the player earns 30 points. And so x is the number of levels. So that's my x, that's my y. And so let's find out. I'm going to go into Desmos and we're going to see, is f of 50, does that equal 30? And I'm going to go ahead and read through the rest of it too. Each level completed adds 50 points to the total. That would be like my slope sort of a thing. Is the slope 50? No, the slope is 30. After completing 5 levels, the player earns 200 points. So I need to know, is f of 5 equal to 200? Each player starts with 30 points. And so does a player start with 30 points? No, they start with 50. That's the y-intercept. And so that should be 50. So we need to see which one of these are true. And so I'm going to go ahead, pause. I'm going to go into Desmos, and we're going to put this just like we did up here. All right, so here we go. So again, we're going to look, is f of 50 30 or is f of 5 200? One of those has to be true. And so I put into Desmos, f of x equals 50 plus 30x, just like it was on the paper. F of 50 is 1,550. That is not 30. F of 5, though, is 200. And so f of 5 is going to be the correct answer. And so that one's correct, that one's not. So C is the correct answer. And that completes our review. If you have any questions, feel free to reach out to me.